The principle of energy transformations in stellar metamorphosis. Hi, Celeste. An energy transformation is when you have, say for instance, gravitational potential energy, like as if a pen is right here and I drop it. That gravitational potential energy is transformed into kinetic energy, to friction with the air, and to sound energy. So there's a lot of things going on there, even though it happens really fast. And you don't really, see it. You don't see the air heating up. You don't feel the air heating up. But you can hear the sound, and you can see that it bounces and it does its thing. For this paper, I wanted to state the importance of understanding that stars are the primary location for energy transformations in the universe, because they are the primary locations for the majority of the chemistry that happens in the universe. Majority of the chemistry, physical chemistry, chemicals, formation, the formation of life, the formation of the largest, most solid structures in the universe that astronomers call planet. Unfortunately, modern astronomers continue to ignore this major discovery by referring to stars and planets as being mutually exclusive objects. Now, I know they do because I printed this gravitational collapse page on Wikipedia, and they still do it. Check it out. It says here, over time, an initial relatively smooth distribution of matter will collapse to form pockets of higher density, typically creating a hierarchy of condensed structures such as clusters of galaxies, stellar groups, stars, and planets. It's not stars and planets, people. The star is the young planet. So, gravitational collapse in this Wikipedia article should actually be the star gravitationally collapses and forms the planet. So the planet is the ancient star. In terms of energy transformations for this paper, there are many different ways the energy can be transformed. And to explain it simply, just like the pen example, basically when you have a large star and it has all this mass and it's collapsing on itself, you're not going to get just nothing. It's not going to collapse into some weird black hole. It's not going to explode. All that is nonsense. That's pseudoscience. What's actually going to happen is that material is going to transform, both in matter composition and in the types of energy that's being exhibited. For instance, if you have a gas-type object such as Jupiter collapsing on itself continually, it's squeezing itself. So there's going to be a lot of internal heat production. And that heat that's being produced inside the star is going to allow for different chemistry to occur. We call that thermochemistry, where specific elements combine together to make molecules based off of their ability to absorb or radiate heat back into the environment. As well, you have mostly the kinetic energy of that star collapsing on itself is a direct result, or directly the cause of why there are winds and there are huge bands on Jupiter, for instance. You see those bands on Jupiter if you take a time-lapse video on YouTube and you watch it, and you see those bands moving across Jupiter. The reason why that's occurring is because Jupiter is collapsing on itself. Think of when you're wringing out a wash rag in the shower and you squeeze it. The same thing is happening with Jupiter. If you squeeze a three-dimensional object in outer space with gravitation, it's not going to fall perfectly in towards the center like this. What's going to happen is the material is going to continue sorting itself out based off of how easy it is to fall into the center, how heavy it is, the chemical makeup of it, and that's going to cause the star to twist and to rearrange all those chemicals as it's collapsing on itself. That's why you have those bands on Jupiter. That's why you have huge winds and gas giants, is because they're squeezing themselves and that energy is manifesting itself in different ways. That's what energy transformations are. Let's see here. I also have another thing here. Here's another very weird way of looking at these energy transformations too. I put this in the paper too. So you have Lorentz forces. You have magnetic energy, which is basically electromagnetic energy. You have thermal energy. You have kinetic energy. This is energy of stuff that's moving. This is heat, basically, and this is electromagnetism. So when you have, stars having all these different types of energy, it's not going to be to where, say for instance, you have like a campfire. It's not like you can start a campfire up and you're not going to be able to feel the heat. That heat's going to transfer directly to your hands and you're going to feel the heat from that campfire. The energy that's present in every single physical body in the universe is always going to constantly be interacting with the universe all the time. You're not going to be able to close it off into a black box. Which means if you have something moving on a star that has kinetic energy, there's going to be production of magnetic fields, electromagnetic fields, because there's lots of ionized material that's going to be moving around, producing electromagnetic fields. As well, if you have those fields interacting and causing a lot of ionized material to form like strings of ionized matter, that's going to be similar to like an electric current, and then that electric current can then heat up material like a lightning bolt does. If you could produce strings of ionized material like a lightning bolt and transfer charge that way, you can heat things up. And the sun does that in huge scales, which means that electric current is ohmic heating, which then transfers into thermal energy. And that thermal energy continues radiating outwards. That's basically why the sun's really, really hot. And you also have things like compression heating through kinetic energy. The reason why there's lava coming out of the earth, magma coming out of the earth in the form of lava, is because the entire earth is still crushing itself. The entire earth's crust is squeezing all that rock and collapsing on it. And how to explain that is like those little toys where, or actually better yet, those little toys where it's like a tube, like a clear tube, and you have a piston in it. And you put like a little piece of cotton at the bottom of it, and you take that piston and you slam it together, and the heat from that air compressing can heat that cotton up and catch it on fire. And that's just from the heat of compression of air. And that's basically also how diesel engines work. If you have that incredibly fast compression of air, of oxygen around that plug, it reaches a point to where it basically self-ignites. I think plugs are only used for starting the engine, but then once that feedback loop is carried back, the engine can run just off the piston compressing the air. There's no spark plugs needed like as in a gasoline engine. So just the runoff of compression of air mixed with the diesel fuel. But that's a big time energy transformation. The momentum of those crankshafts inside of diesel engines, that they can continue on and keep that engine running, and you don't even have to have spark plugs in there, which is really cool. See what other type of energy transformations are there. That's basically this talk in a nutshell. And the reason why I wanted to go over this is astronomers and astrophysicists they sort of try to wall themselves off with a bunch of math formulas and things nobody really understands. Their idea of gravitational collapse, which is gravitational potential energy transforming into kinetic energy, their idea of that is that it only happens in exotic structures. No, that's the very basics of how something as massive as the Earth forms. Gravitational collapse and the energy transformations that occur due to gravitational collapse are what allow the universe to form structures as massive as the Earth. But astronomers, they're not gonna want you to know about that because, it makes them look bad. They're gonna realize that, yeah, the processes that involve stellar evolution are the same processes that a planet forms from. Instead, they want you to go look at disks. A big disk is what forms something as massive as the Earth. But it's very strange. How does a disk have orientation for gravitational collapse? It takes something that has a pre-existing gravitational field around it to cause the gravitational collapse. A disk orientation around something like the sun, as in the protoplanetary disk model, it gives off it's a disk shape, which shows us that there's no large gravitational field. If there was a gravitational field, there would be no disk shape. It would be spherical by its very nature. But what they want you to believe is somehow that objects form in a big disk. But it's very strange. Their ideas are very, very strange. They don't realize that spherical structures beget spherical structures. Once that star is born from a large electromagnetic event, it expands and it retains its spherical structure as it evolves and gravitational collapses. But anyways, I think I made this talk way too long. All right, y'all, later.